I understand that probably you haven't completed the PCB design yet, at least most of you. And since I would like to see the final report with all the design on the website as a report on Friday, right? Before the beginning of class, even though you are not coming on Friday. And so here's the thing. I do not want to give a lecture, since we have two groups covering different tutorials, and I do not want to give a tutorial or lecture on your group's tutorial on Monday because two groups are in the class. And what's going to happen for the next tutorial is some fundamentals of Arduinos. And this will be a pretty short lecture. I'll just introduce some of the fundamental things to you and one example at the end of the tutorial, which is a homework assignment you are going to work with. Not this one. This one. So see the schedule. I'm planning on give you a short lecture today. So after you are done with your PCB on Friday, you'll still have something to do next Monday. Okay. And you are not going to start doing anything new by Wednesday next week. So I'll give you another lecture on Wednesday next week. So you are supposed to finish the PCB design by Friday this week, the day after tomorrow. And whatever I'm going to introduce in this lecture, and you'll start working with that with all these Arduino kits. But very simple and fundamental examples. It can be a little bit intense because there are quite a few of them, even though they are simple. So after Friday, you submit your PCB report to the website, and you can start working with this one. You can watch the video I'm going to record today, and any examples you can search from my previous lectures or online anywhere, and start working on that. So you have Friday, the weekends, Monday, Tuesday, to finish all these examples, plus a report. No, actually Wednesday, Wednesday and Thursday as well next week. So it won't be due next Friday, but you will have a new lecture on Thursday, on Wednesday. Is that making sense? I'm here to confuse you. That's my job. So, so today's lecture, Arduino Basics, right? And I will let you check out this one if you are ready. And you'll start working on that after you are done with the PCB tutorial. And the report for this one is due Friday next week. I haven't put it here, but I'm going to add that comment here. So this one due Friday next week. Okay, so you have the entire week to work with this tutorial, which is here. So all the tasks are included into this tutorial. Okay. And after I see your PCB report on the website, so again, I'm not expecting a super long report. I just need to see the key parts. If the schematic is right, if you have a DRC clean, if the layout is correct, looks correct, and also you need to upload your Gerber file to a PCB viewer online of any of the free website is fine to show me different views like the silk screen, solder mask. If you have a T-stop to stop the solder mask to cover the metal pad of the DC regulator, the 3 amp one. Do you know what is that one? I mentioned that, right, in the class? You don't? I'm doing too fast, probably. Am I doing this too fast? What about the pace of this class so far? Should I include more details? Or since every single student in the class probably has a different pace. If I spend the entire class to demonstrate every single step for the PCB design, I think it's not worth it. So what I'm thinking is I expect you guys, when you are working, follow the tutorials, whenever you have a question, any kind of question, do not be shy, just ask me, email me. Or if I'm here, ask me in person. If I'm not here, email me. And I have my office hours are Monday, Wednesday, Friday from 9 a.m. to 11 a.m., even though you are not available during that time frame. So normally, whenever you email me, I will reply to you as soon as possible. That's what I normally do. So email me if you have any questions. Do not stuck to anywhere for a really long time. It's frustrating. As a beginner for PCB design, it really takes time. And if you mess up with a grid, for example, you cannot snap your voltage nodes to the wires. It's super frustrating. You connect everything together, you are done with the PCB, but finally you find out they are not being connected. You do a DRC check, you see 100 errors because you have changed the grid setting every time you entered PCB. So you need to use the same grid setting for everything, for the library, for the schematic, not schematic. Schematic, they need to use the same grid. But for the layout view, you need to use the same grid all the time to make sure after you drag a wire, you click connect, you can connect to that point. They have to be on the same grid. If you're not seeing that, I'm sorry, you have to restart everything. But I believe the second time you start over everything, it will be way easier. It will be way faster. And sometimes it's not a totally bad thing. Whenever you are getting frustrated by making mistakes in Eagle PCB, you actually start hating that, and you actually be more familiar with it since you have to look at it for a long time and you hate it and still remember it. I mean, the next time it will be way faster than the first time, I believe. You can hate Eagle PCB, but do not hate me, okay? I'm going to pay for the PCB fabrication for you. Why do you hate me? You shouldn't hate me. I'm going to pay for that. Pay that for you. So hopefully everybody can get a PCB, a power module fabricated. So you submit your report to the website. I'm going to review everything. So make sure you have all the information for me to check the correctness of your PCB board online. And if I didn't see any problems, I will go ahead and directly fabricate it. If I see issues, I'll let you know. If I'm not emailing you or let you know anything, that means it's fine. I will go ahead and submit it for fabrication. Otherwise, I'll let you know. Probably it's going to take me a lot of time to communicate with you to figure out, clean up any single issue on the board. But we will make it. That's the purpose of this course. It's fine to make mistakes at the very beginning, but finally you need a functioning power module which you can use throughout the semester. Probably you can. I'm going to give it to you. I'm not keeping that. Okay. You can keep the power module whenever you need to use it in your senior design, junior design, wherever. Okay, you can have a little power module with you. Let's get this done by this week. And I don't want to do this for 3 weeks because the name of this class is Microcontrollers, not Microcontrollers power modules. So let's get this done and move forward with all these interesting and fascinating projects. Let's take a look at Arduino Basics. So before we start this one, I know a couple of you guys were in my logic class in the summer, so you probably still remember this. And some of you were in my digital electronics a few years ago. It can be a little bit challenging, but none of this stuff are challenging. So it's just trying to remind you, what are they? What is this? Can you see? Okay. So how do you pronounce this? I just watched the news a couple of days ago. I mean, the reporter saying one guy in the office, were politician, right? So he's supposed to know the country's names, but actually he doesn't. And he pronounced the two countries in Asia, which is Nepal and Bhutan. You know these two countries? And he pronounced these two countries as nipple and button. You know who is him, but anyway. So pronunciation is important. We do need somebody who knows what's going on in the office, right? It's kind of. All right, what is this? How to pronounce it first? A times 0. No, right? A and 0. A is a case. So A can be 1, can be 0. Right? A and 0 is what? A and 1. A, 1 and 0. Two. Huh? Uh-huh. Do you all agree with that? If you forget everything about this, it's hard to move forward for this class. Computer logic is a prerequisite and only prerequisite for this class. You can imagine. If you forget everything here, go back to my online logic lectures, videos, do the homework assignments for the first 2 to 3 weeks, and then come back. A, right? All right. What is this? Since I told you my job is to confuse you, that's why I introduced this cross sign after this, but actually this is not AND logic. If you type this in Arduinos or any C language programming IDE, it's actually 0x. So this represents what? What is this? That's hex. If you see 0x something when you're programming, right? So that's a hex number. So this is a hex number. So BC for B and C, how many binary bits in total for B and C? How many binary bits in B? And how many binary bits in C as a hex number? What is B? 11. What is C? 12. How many binary bits for B and C for each, or respectively? So hex means you need to carry out after 15. You do not have 16 in the hex number, right? So start from 0 and you count until 15. You have to carry. What is 15 in hex? What is 15 in hex? F. So in hex, that's decimal. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. These are decimal numbers, and the corresponding hex numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, G. G as George? No? Then what? That's the very basic ones, right? In your learning logic. Let me know what's the next. 1, 0. Okay, so that's hex. So, because hex numbers are from 0 to 15, so if you want to represent a hex number, you only need up to 4 binary bits to represent it. Why? Because what is this? What is this? That's number 3 in Chinese. What is this? Number 4 in Chinese? No. We change it to this. That's number 4. Anyway, what is this in binary? What is this? Huh? 8? What is this? 1. What is this? 2. What is this? 4. What is this? 8. Add them together. What is it? 3, 7. Is that 15? Is that F? Okay. So that's the maximum number you are going to have in one single digit of a hex number. And you only need 4 bits to represent it. So here in this, if you write in this form, every single hex digit represent how many binary bits? 4. So what is B? What is C? So this equals to what in the binary form? So if you want to write a binary number in your programming IDE, you need to start with 0B. So the IDE knows it's a binary number, it's not a decimal number. If you write a 13 directly, it's recognized as a decimal number by default. Keep in mind. So you have to start with 0B. If you are writing a hex number, you have to start with a 0x. So this equals to 0B what? Yeah, so B is 11, right? 11 means 8 plus 3. And the second four binary bits here, 12, is 1100. So that's a hex format, that's a binary format. And you have to convert this one into a decimal. If you want to use a decimal numbers format, you got to convert it and then directly write down that number in your programming when you're programming something. Okay? Is that clear for everything here? There are some operators. That's this is just a simply logic and that's simply logic or. So why do we need a bitwise and an or logic in programming? Why do we need that? It's a pretty important technique when you're programming embedded systems. It's kind of different from the upper level, higher level programming languages you have learned. This is more a bottom end or back end programming, so you are touching the hardware directly. That's why sometimes you need to use a bitwise and an OR, so you can toggle specific pins of the hardware. When you're programming your C++ or Python using your laptop or desktop, you're considering any of the hardware pins on the CPU of your Intel Core i7 CPU. Do you know what are the functions of any specific pins of the CPU? You have never thought about it, right? The operating system has done everything for you. But here it's different. You directly interface with the pins. So you need to know these things. Why is this significant? Let's look at one example here. A equals to, that's not right, right? So I'm going to do something assigned to A. 0B, 1011, 0B, 0100. What's going to happen? What's going to be stored in A afterwards? And what is this? Answer these questions. So what is this operator? Bitwise AND. Okay? The reason we need a bitwise AND is because they are multi-bit binary numbers. It's not making sense to do AND logic for the entire number since they are not 1, 0. It has multiple bits and it's a pretty larger number. Not pretty large, but larger than 1, 0. It's not 1, 0. So bitwise AND, you are actually doing an AND operation for all the bits one by one. So what's the result? 0, 0, 0, 0, right? You do an AND operation for every single bit for the two binary numbers. So A family will be 0, B, 0, 0, 0, 0, which actually 0B, 0, 0, 0, 0, 0 equals to 0 in decimal. If you write this in, type this in your Arduino IDE, they are equivalent. So 0, a single 0, which is in a decimal form, equals to 0B, 0, 0, 0, 0, which is a 4-bit binary number. Same concept for bitwise OR logic. So I'm not giving you more examples about that. And also there are some other things you need to know. You must read the entire tutorial here on the website. Read it. And some of the tasks I'm asking you to repeat it and have a snapshot for your report. That's what you need to do for this entire thing. But you are not retyping everything or copy and paste all these paragraphs. But you are just repeating some of the examples. I have all the tasks here at the bottom of the page, so you know what you are going to do. When you are reading this tutorial, make sure you understand some key things, especially the data types here. And every single data type has its specific length because we are going to use the Arduino Uno microcontroller, which has a Atmega 328P CPU chip, which is the 8-bit CPU chip. It takes all this binary data in the form of 8-bit binary numbers. Probably it's not super clear why, right? So when they design the computer, they have a memory in the form of 8-bit length. So they take all these numbers and do addition, subtract, and division, all these operations, calculations in the CPU, and give you a result. That's how that works. So this is the 8-bit computer system. Doesn't like your laptop or desktop, which is 64-bit. So which means your desktop has all these memory banks, and every single memory unit has 64 binary bits. But here, only 8 bits. Okay. Something you need to know. Byte, the byte data type is an 8-bit data type, and it's unsigned. Keep in mind, it doesn't have a sign. It's all positive, no sign. How to represent a negative number in computer? Do you still remember that? Yeah, let's get a quiz on two's complement. How does a computer represent a negative number in the memory banks or in anywhere in the computer? Two's complement, right? Two's complement. If you have forgot that, go back to the lecture videos. I have everything on my YouTube channel. Just watch them. Two's complement for signed binary numbers. The byte data type is an unsigned data type. So do not assign any negative number to byte data type. Integer is a 16-bit data type. You must be wondering, it's an 8-bit computer system. How can you have 16-bit numbers in there? How? Just combine two memory units. Okay, so it is able to combine two of them to represent anything larger than 8 bits. The computer will do everything for you, so you don't have to think about all these details when you're programming. It doesn't, so it's different from assembly language. It's a little bit higher level. The Arduino C programming language is a lot easier than assembly, and it's totally not necessary to program a microcontroller use assembly. It probably will take you 10 times longer to develop a system if you're using assembly, but rather than not a C language. Okay, that's why we are not doing assembly programming at all for this class. You are going to learn assembly in CE451, computer architecture, and I think Professor Nishatu Majid, he's going to cover ARM, the ARM architecture and RISC-V architecture, and let you program assembly. Okay, hope you will survive after that. You could imagine how many people change their major after they learn assembly. When I was in college, they just kill themselves and change the major. Something to know. But normally, you are not going to touch it if you are just programming or developing embedded systems. You don't have to. All right, so read all these descriptions for these data types. I know you couldn't remember that, but after you have so many chances to use them in your program, you will know how to use it later on. So no worries for now. These operators is pretty similar to MATLAB. If you have learned MATLAB in 104 or C++1, it's very similar. So I would just let you to read it. So after you practice on that with the board, you can actually memorize everything easier and quicker. So do not spend too much time on this. Just skim through everything, trying to recall your memory, whatever you have learned in 104 or 122. And all these functions pretty similar compared to C++ and MATLAB. Very similar. There are some examples for using loops, the if statement, switch switch and cases do well for, and then you got here the bit masks. Okay, that's one of the homework assignments you need to do after you read all these tutorials. Like I just gave you that example, that was a 4-bit binary number, but here is a 8-bit binary number, X and Y. So see, X is this, Y is this, and X and Y, and use a bitwise AND operator, you are getting this. It's literally just do an AND logic, AND operation for every single bit. That's a bitwise OR. And this guy is a left shift. Left shift. This operator is a left shift. If you have a binary number which is 1010 and shift this binary number to the left by 1 bit, what's the result? There's nothing on the right. How that works? So as I said, the Arduino microcontroller has an 8-bit computer system. So every memory unit has 8 bits. And if you assign 1010 to a variable, you're getting this. What about the rest? You gotta assign a value to it. The compiler knows that, okay? And it's gonna directly put a 0 in there. 0 volts, right? Ground. So that's your 4-bit binary number in Arduino. If you have a 64-bit binary system, then there will be like 60 zeros in the front. But this is 8-bit, so I only have 4. So in that case, if you left shift this guy to the left by 1 bit, what's the result? So everything will be shifted to the left, and they will put a 0 to the end. Okay, make sense? What about move to the right? So if you move this number to the right by 1 bit, so this 0 will be will be eliminated from this 8-bit binary number. So you are actually getting, so this is left shift by 1, right? So if you do right shift by 1, you're getting 0, 0, 0, 0. And it's going to make up another 0 here, but shift everything to the right. So that's the final result. So that's what you need to know. What's going to happen if you move this binary number to the left or to the right? Is that clear? Okay. So here's example. I think I need to let you know how to do that. So read the description here really quick and let me know what you think. How can you solve this problem? Number 6. So the bit masks are pretty important technique when you are programming an embedded system. But this is just one very simple example here. But this example has the data given already. If you look at the code, the example code here, data is 170. So actually you know it already. There might be a case in the future you have a number comes in or data comes in, but you do not know what's in there. So you can use a mask, the bit mask, to take out every single bit from the data and display to somewhere. So here's the data. How many bits? 8. So 8 bits is 1 what? 1 byte, right? Is it? Right? Okay. We don't know what's going on inside. We don't know what are they. But however, I have a tool. I have a tool. The tool is called the Bitmask. What is this one in your memory unit? 7 zeros and 1 single one as a LSB. What is LSB? Stands for? The least significant bit, right? So if I assign 1 to this variable, I'm actually assigning this binary 8-bit binary number to the memory. And this is called the MSB, and this is called the LSB. Okay. So literally, this guy is 0B000000001. So what I'm going to do is I will do a data bitwise AND the mask and assign the result to a variable. What's going to happen? Do a bitwise AND in between mask and data. What's going to happen? It can be 0 or not 0. And if it's 0, what does that mean? If you are getting 0, which means this single digit is 0. Is that true? Does that matter for the other bits? No, because I have zeros to have an AND operation with every single one in the front. So it's going to be a 0 anyway. I know that. However, 1 and this guy will still be this guy. Remember, this is A. 1 and A is still A. If I'm getting a final result to be 0, which means A is 0. If I'm getting a final result to be non-zero, which means A is 1. Is that clear? Is that true? You agree with that, everybody here? Okay. So in the next loop, I'm having a loop here. In the next cycle, I'm going to left shift the mask to the left side by 1 bit. And I do the same AND operation with the data. So I can tell if this guy is 1 or not. So on and so forth. So I can check all the bits in the data if they are 1 or zeros. Is that true? Is that correct? Do you have any other possibilities other than 1 zeros? No. So if it's not 0, it's going to be 1. If it's not 1, it's going to be 0. Easy to tell. So after the entire process, you will be able to tell what are the what's every single bit in this data. Okay. After that, after every single loop, you store that result into array. So you have array something like that, and start with 0, the position 0. Every single time you assign that result, won't be that result, but will be something here to that array, so you can recover everything the data here. And everything will be stored in this array, and you need to export all these numbers here to the physical pins, I/O pins of the Arduino to turn on and turn off the LED. So that's a task for this tutorial, number 6. Okay, let's write a pseudocode for this one. See if that helps. You know what I mean? So it has quite a few digital I/O pins. So these ones probably can. I'm asking for 5 binary bits. So you're actually connecting 5 LEDs to the I/O pins with a protection resistor. Don't forget about that. So like here, you have a resistor. It can be 220 ohms to 1K, doesn't matter. And has a LED and ground. Okay, and you need 5. Is that clear? So after you find out 5 binary bits, starting from the right side, from the LSB, you find out the number of these 5 bits here, and then you need to send all these binary values to the pins. If it is high, it's going to turn on the LED. If it's low, it's going to turn off the LED. So you're actually displaying using 5 LEDs to show the leads, the 5 bits from the LSB in the data. To make it short, I give you a data, which is an 8-bit binary number. Doesn't matter what it is. I'm not telling you, or I can tell you what is that data. Okay. So so from the bit 0 to bit 4, which has 5 binary bits, I don't know what are they. Okay, and you need to use a Bitmask to find out what are they. Like this, right? So 5 pins, 5 numbers, and send it to the pins to turn on and turn off the LEDs. So whatever here need to be displayed by the LEDs. That's it. That's what you need to do. And you have to use the Bitmask to do this. Okay. So for the details, you can be creative about how you can do that. But you do need to finally implement this little function for this homework assignment. And this will be the final course project for this course. No, just for this homework assignment. And due in 1 week. Okay, let's take a look. Pseudocode. All right. So how can I get started? When you are programming Arduino or with any other embedded systems, you must be wondering, like, where can I get started? So I suggest you start from the main function. So just think about whatever I just described. You just need a computer to do whatever I just described for you, instead of you are doing that, but you want a computer to do that. Okay? Something like you have somebody to help you, and you have to know what that guy can do in order to let him to do this. If you know nothing about what he can do, you just couldn't program it since you just don't know where to get started. So what that one can do, it can do loops, can do the if statement, can make a judgment, can do a really quick scanning for all the digital pins on the board, all these kind of things. It can run fast. The frequency of the CPU of the 328P at a mega CPU chip is oscillating at 16 megahertz. So it has all the clock frequency, all the little clocks to trigger all the changes inside the CPU at a frequency of 16 megahertz. So 16 mega pulses every single second. Okay, so you need to know this guy can do this, and now you know how to program it. Okay, let's take a look real quick. Think about it. I need something. That's the main function here. First of all, I need a mask, and also I need the data. And what I'm going to do is I'm going to do a bitwise AND operation for every single loop, and I'm going to loop it so I can left shift this guy every time. And for the result for every single bitwise AND operation, I get a result, and I need to store that result somewhere so I'm not losing that. So finally, I get a final result, so I know what's going on in here, so I can send that final result to the digital pins to turn on and turn off the LEDs. That's it. That's what I need to do, or that's what the little microcontroller chip need to do for me. To get started, don't worry about all these constants you need to declare in the front, or any setup statement you need to do in the setup function, or don't worry about anything else. Just write down the main function first, so you can build a frame, build a structure, and then you can fill in all these different things. You can add all these statements in the front or later. Okay. So what's the main thing here? Let's take a look. What's the main thing? I do need a data. So you need to declare that, which is a byte. It's an 8-bit binary number. So I will give the data here for you. As a binary number, you can say 0, 0, 0, 1, 0, 1, 1, 0, something like that. So now I have the data, at least. So here's where we want to get started. I got the data, I need a mask. So the mask is also a byte. And so mask, I will give 1 to the mask. Okay? So what is 1 in the memory unit? 7 zeros in the front, and LSB is 1. That's when I assign this guy to here, it is actually 0, 0, 7 zeros, and 1. So that's your mask. So I have a mask, I have a data. So what I can do is I can do a loop, because I'm asking in the problem, I'm asking to do a 5-bit binary number. So I only care about the 5 bits here. So I only need a loop, which can do 5 iterations. So in your loop function, so that's loop function is not returning anything, but you're going to use this all the time in the future. So here's a loop function. And first of all, what you need to do, you need a loop, since you need to left shift your mask all the time. So for I need an I. Integer, 16-bit. Initial value 0, and if I is smaller than 5, since I need 5 loops, then +1 to I itself. So I start the loop. So now do the judgment. If data bitwise and the mask. What does that mean? If this and this, if you don't say anything, if this and this is what? No, I don't have to say anything. The by default is true. So if this and this is true, so true means non-zero. It doesn't have to be 1, 2, 3, 4, 5. If it's 0, it's going to be false. If it's non-zero, it's true. If this is true, which means it's not 0, then what? Then I know for the first loop, I'm doing an AND operation here, bitwise AND. So if this is non-zero after the bitwise AND operation, if this is true, what does that mean? What's this telling me? So here, this is a bitwise AND, right? And for the first loop, I'm not shifting yet. For the first loop, so here's the mask, here's the data. I'm doing a bitwise AND. Every single bit here will be canceled to 0 because this is 0 and this one is going to be 0. But however, I know it's 0, but I mean, if it's not 0, what does that mean? Huh? If it's not 0, it's going to be 1. That's good for digital, only 2 cases. If it's not 0, it has to be 1. So if this is non-zero, if I don't say anything here, which means if this is true, which means if this is non-zero, also means this guy is 1. I know it's not 1, but you have to put this if statement over here, right? You'll have an else later, but no, it's if this is true, literally means if this is 1, you got a 1. You know the LSB for the data is 1. That's done. You're done for the first bit. If it is 1, what you want to do? Oh, I get a data. What you want to do? Drop it. You want to save it somewhere. Save it in an array. Oops, I need an array. Let's get an array. So every single digit in the array is an integer. I just name it as data display, so the data to be displayed. And I have 5 spots in the array, so 5 bits in the array. So if it's true, I know the first bit will be 1 or 0. If this is true, this will be 1 or 0. 1. So what do we want to put in here? What should be in here? I. Because I is 0 for the first loop. Okay, so you have a 1 here already, and you get this data, you just store this in the array. So whenever you have this curly bracket, make sure this one is aligned with this guy. Okay. Else, that's pretty simple. Because it's not 1, it's going to be 0. Also I. As a curly bracket aligned with your else. I'm thinking I'm done. Let's wrap it up and see if there's any problems. So after all these processes are done for the for loop, So here's a curly bracket aligned with this for loop. So you can imagine there will be an array called data disk, has 5 bits, and every single bit is going to store every bit here in the data. Okay, so all these ones will be stored in here, and I'm going to try to send all these bits to the digital pins to display. So whatever you need to do is actually after this, okay, you have to do this digital write. For example, I connect the pin 13 and I'm sending data display 0 to 13, and I do digital write, and I connect another LED to pin 12, and I do this, so on and so forth. Uh, 13, 12, 11, 10, 9. Uh, 4. All right, so that's the end of the entire loop function, and this one should be aligned to the void function here. Okay. So you are thinking about, hey, sending every single binary number to the digital pin one by one. So you are probably seeing it's being turned on, being turned off in a consecutive order. I don't know, just one by one like this. Is that true? See that you have a different a specific order. I'm going to send this data to 13, and then send this data to 12, and then this. So it sounds like it's not sending all the data to the pins at the same time. So like these pins, right? I want to send it in parallel, like boom. But actually, it's doing like this, boom, 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 like this. Is that true? Can you tell that? No, because it's running super fast. So that's a loop. After you power up your Arduino, it's going to run a loop like this, like this. So your eye couldn't tell it. So it looks like it's assigning all the numbers to the 5 pins at the same time. That's one of the advantages you want to use for a microcontroller. That's because you can run everything really fast. So there are 2 minutes, 2 more minutes, I'm sorry for extending this. And think about that. There is something I didn't finish. You do need a void setup. So after you read the tutorial, you'll know what you want to put in here. Okay, here's a setup function to set up the digital pins here to be output mode. That's one thing you need to do. Another thing, think about one problem here. I am shifting. Did I shift? I haven't shifted anything. Did I shift? Did I shift the mask? I didn't shift it. Do you need to shift it? Every single loop, you need an updated mask. Since you are shifting that bit, boom, boom, to the left every time. So I make a judgment, where do you want to insert that shift, left shift, in every loop. All right? So, for example, you can do it here. Here as well. Okay? One more thing, still not done yet. What is that saying? Is there any bug for this code? See what's going on here, okay? Let me show it for you. You have a data, you have a mask. You have a data, you have a mask, okay? And now you are shifting. You are doing AND logic, and you get a result, shift, and shift, and shift, and shift, and. After you are done in the for loop, you have shifted that one for 5 times. So get 5 binary bits. You think you are done. However, the loop will run forever. That's a forever loop. What's going to happen in the future? What's going to happen in the future? What's going to happen in the future? Did you reset the mask? You didn't reset the mask. What's going to happen? You reset the I, which is true. You're updating your array because I is always being reset to 0 every time. But however, did you reset your mask? What's going to happen? That little port 1 at the very beginning on the LSB will be shifted to where? To the Mars. So you want to reset the mask. Where? You will tell that, okay? Make a judgment where you want to reset the mask. All right, that's it for this. Ask me any questions.